Hello student, today in my 8th lecture we are going to discuss don't care condition. This is another part of K-map. It is slightly different from K-map but the same property we have to use here. All the 6 properties of K-map again you have to use here. As the name suggests, don't care. Normally we are using this word in our day-to-day life. Nearly the meaning is same in K-map. But first I am going to explain you what is don't care. See, in some digital system, certain input condition never occurs. So there is no possibility of output. Such conditions are said to be don't care condition. Suppose in a apartment, suppose you are given a 7-segment LED. So in 7-segment LED, it is, I think you have studied in lower standard. This is 7-segment LED. 7 diodes are there, and the number display is 0, 1, 2 up to 9. Suppose this is being used as an indicator of lift, elevator. One building that is of only 7 floors. So for that we required digits 0, 1, 2 up to 7. 8 and 9 floors are not there. So that means 8 and 9 are don't care condition. This is the meaning. Okay. Now exactly the meaning of don't care is here. In some digital system, certain input condition never occur during normal operation. Hence, there is no chance of its output. Such conditions are don't care condition. In some digital system, certain input condition never occurs, floor number 8 and 9, okay, during the normal operation. Hence, there is no chance of its output. Such conditions are said to be don't care condition. Symbolically, it is represented by symbol X. It is represented by symbol X. In K-map, to simplify the Boolean equation, you have to place 0 or 1. You can place anything, 0 or 1, but you have to prepare simplest Boolean equation. Okay, so there is no thumb rule. Okay, you have to place 0 or you have to place 1. So you can apply both, either 0 or 1. But the condition is your equation is the simplest one. Okay, is that clear? Okay. Let's discuss few examples related to don't care. But first, again, in some digital systems, certain input conditions never occurs during the normal operations. Hence, there is no chance of its output. Such conditions are don't care conditions In K-map, such don't care conditions are represented by symbol X, and to simplify K-map, you can place either 0 or 1. Clear? Let's discuss few examples related to this. Suppose you are given a K-map in which entries are like this. First 8 entries 0. These entries are don't care, 1, 2, 3, 4, 5, 6, 6 are don't care, 1 is high, the rest one is 0. Such type of K-map is given. Now, you can place 0 or 1, okay, but your K-map should be a simplified one. So, we are going to discuss different cases. What is going to happen if we place all zeros, if we place all 1, okay. So, the first one, now suppose one student say that, sir, we are placing all 1 in place of X, okay. So this is your K-map, and let's have an entry, octet, quad, pair. In this situation, 1, 2, and 3. We have 3 quad, no pair. When we are placing all ones, okay, 1, 2, and 3. Okay. In another scenario, suppose the student says, sir, place all zeros, okay. Then you have single variable. So in that case, 0, 0, 0, and 1. And your Y is A, B bar, C bar, D. Okay, I will tell you both answers are wrong. One more, even better combination is possible. So let us observe this one. Suppose one student say, sir, this is the best example. 1, 2, and 3. These 3 X are high and the rest one is 0. Then you have only one quad and your Y equals to B bar cancel, A, C bar cancel, and D. So this both conditions are wrong. Here we have placed all ones, here we have placed all zeros. It's wrong. This is the best one. Okay, so you have to choose 0 or 1 in such a way that your Boolean equation is the simplest one. See, here we have a single variable, but then y equals to a b bar c bar d. So if you compare with this one, here only ad. So this is the correct circuit. So it looks simple, but you have to place 0 and 1 appropriately. Otherwise, your answer is wrong. Clear? Okay. So 3 more examples we are going to discuss. Normally such type of question is asked for 7 marks. Okay. Y equals to f a b c d, that means 4 variable K-map, sigma m 4 5 7 11, that means for the state number 4 5 7 and 11 your output is high. D means don't care for state number 12 13 14 15. Okay, so 4 variable K-map, output is high for 4 5 7 11 and don't care is for 12 13 14 15. Okay, so first we have to plot state-wise diagram. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This is your state-wise diagram. Now after this, you have to place 0, 1 and x at appropriate place. A bar B bar, A bar B, AB, AB bar, C bar D bar, C bar D, CD and CD bar. 4 means 0, 1, 2, 3 all are zeros. 4 and 5 are high, 7 is high, 6 is 0, 12, 13, 14, 15, that is don't care, 12, 13, 14, 15, 8, 0, 9, 0, 11, high, and 10, 0, 4, 5, 7, 11, high, 12, 13, 14, 15, don't care. Now you have to simplify this K-map by placing zeros and 1 at appropriate places. Okay. C bar, D bar, C bar, D, CD, CD bar, A bar, B bar, A bar, B, AB, AB bar. First 4 entries 0. Next 1, 1, 1, 0. Now look at these two ones. If I am going to place 1, then quad is possible. For this 2, yes, also quad is possible. So 1, 1, 1. So there is a formation of 2 quad. Okay. Now here there is a 1. But this one is 0. So combination of 4 ones is not possible. So you have a pair. This X is absolutely useless. Okay. So place 0 for this. So 1, 2, 3. For this 3x you have 1. And for this one it is 0. So finally, your combination octet, quad and pair. You have 2 quad and a pair. And your y equals to, for this one, A bar cancel, D bar cancel, so BD, BC bar, BC bar. For this part, A bar cancel, so B, and C bar cancel, so D. So plus BD, plus for this pair, B bar cancel, so ACD. So your y equals to A bar cancel, BC bar, for this one CC bar cancel, so BD, and for this part B bar cancel, so ACD. Okay, so this is the simplest form of your K-map in particular don't care condition. Okay, now if I am going to make only one change in the K-map, the entire scenario is going to change. Okay. Okay. Number 2. Show the K-map for the following one. Only one change. 3 is added here. In previous example, output is high for state number 4, 5, 7, 11. Now here it is for 3, 4, 5, 7, 11. So here is 3. 4 is high, 5 is high, 7 is high, 6 is 0, 12, 13, 14, 15 is high, 8 is 0, 9 is 0, 11 is high, 10 is 0. Okay. So I think this 3 is added here. 4, 5, 7 and 11 is already there in the previous sum. Okay, now this 2, 1 make a pair. These two have quad. So 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So group number 1, group number 2, 0, 0, 1, 0, 0. So you have a pair. You have a pair. So octet 0, 2 quad and a pair. In previous example also we have 2 quad and a pair, but this pair is a different one. It is a combination of these two. Okay, here, because here in that case we have used the rule or property of overlapping. Okay, here we have to use the property of rolling, because if I am going to use another pair here, then it is an example of redundant group, because already pair is used here. Okay, so it's useless. So your answer is going to change. Y equals to, first one, A bar cancel, B, D bar cancel, so BC bar. For this part, it is B, D. So this two remain same, but now pair is going to change. For this two, B bar remain same, A bar cancel. So B bar CD. It is B bar CD. In previous case, I think it is BCD. So be careful. A single error marks 0. Okay. So that is why you have to become very careful when you deal with K-map. Okay. Let's see the third example. Okay, look at here. This is problem number 3. 4 variable K-map. Function A, B, C, D. For 5 and 10 it is high. 2, 3, 7, 9 and 15 it is low. So for 2 it is don't care. 0, 1 and 3. Yeah, 3 is also don't care. Okay, 4, 0, 5 is high, 7 is don't care, 6 not available, 8, 0, 9 is don't care, 10 and 11, 10 is high, 11 not exist, 12, 13, 15 don't care, 14, 0. 5 and 2, 7 and 5 don't care. 1, 2, 3, 4, 5 and 2 are high. Number 5 and 10. This is number 5. Look at here. This is number 10. Look at it. And don't care, it is 2. Where is 2? Yes. 3 here. 7 here. 9 here. And 15 here. These 5 entries are don't care, 2 entries are high. So it looks complicated. 1 is used here. This X, if we use, then pair combination of 4 ones doesn't exist. So as far as this part is concerned, we can have this X1. So we have a group of 2 ones. Okay. So rest place 0. This is 0. Next to 0. Now about this X, it's almost useless. So 0, 0. This one is 0. This X combination is not exist. So 0, 0 and 1. Now here it is 1. So for this X, if I am going to place 1, then we have a pair and here another pair. So we have 2 pair, 0, 0, 2. So your Y equals to this pair, C bar cancel. So A bar, B, D plus. For this pair, A bar cancel, B bar, C D bar. So in this way, at appropriate place, you have to put 0 and 1. Okay. So this is about the don't care condition. You can place 0 or 1, but your equation is the simplest one. Okay, well, that's the last one that is given in your textbook. Okay. This illustration is given in your textbook. Y equals to F A B C D. So 4 variable K-map where output is high for the condition 7, and for 10, 11, 12, 13, 14, 15 it is low. So first 4 entries 0, 7 is high, 10, 11, 10, 11, 12, sorry, they are don't cares, 10, 11, 10, 11, 12, 13, 14, 15, and the rest ones are 0. Okay, so only one, that is number 7, is high, and 6 entries are don't care. So here combination of 4 is not possible. 1, 2, 3. This one is 0. Now if you think 1, 2, 3, 4. Suppose I am going to place here 1, 2, 3, 4. Okay, then it is useless. Why? I'm going to explain you. Suppose and for the remaining this 2 you are going to place 0. Then what happen? you have a 1 quad, still this 1 is left because it is already there, and a pair. Okay, in place of this, if you make all this x in this way, only this one is I and remaining all are 0, then you have a single pair. In previous we have 1 quad 1 pair, but in this, if I am going to prepare the K-map in this way, I have a single pair. So this is more appropriate. So y equals to a bar cancel and b c d. Okay, so you have to apply your mind, think in a different way and find out the solution in which your Boolean equation is in the simplest form. Then only you have a full marks. Okay, in next lecture we are going to discuss product of sum theory. That is the last topic of this chapter. Okay, then this chapter is over. In next session we are going to discuss product of sum and then some SQs related to this chapter. Okay, thank you.